Welcome to BTEC Revision. In today's lesson, we're looking at electric field strength. By the end, we should be able to calculate the electric field strength, forces, and charges. What is a field? A field is a region or space where a object will experience a force. For example, we've got this diagram on the bottom right. Here we have a field produced by a proton. Now, there's many types of fields. In this lesson, we're going to be focusing on electric fields and the strength of the field. In the proton, we have a positive charge, and this is producing a field which has a certain strength. The more lines we have, the greater the field strength is going to be. And this is called the electric field strength. The electric field strength is the force experienced by this unit charge, in this case a proton. It could also be an electron, and can be calculated with the equation electric field strength equals the force divided by the charge. Let's take a look at an example. What is the electric field strength around a proton which has a charge of 1.6 times 10 to the power minus 19, which experiences a force of 1 times 10 to the power minus 10 newtons? We can start by writing down our equation. Electric field strength E equals the force F divided by the charge Q. And we have the values. Force is 1 times 10 to the power minus 10, and charge is 1.6 times 10 to the power minus 19. And this gives us a value of 6.25 times 10 to the power of 8, and the unit is newtons per coulomb. The electric field strength can be different depending upon which object we're looking at. For example, if we take two parallel plates that have opposite charges, like in the diagram below, we have the top charge of positive, bottom charge of negative, and we have electric field strength that is uniform, which means that it's unchanging. So wherever we place a charge, let's say we place an electron over here, which has a negative charge, or we place an electron over here, doesn't matter which position it is, it will always experience the same force. And this strength, electric field strength within two parallel plates, is given by this equation. Electric field strength equals the voltage divided by the distance. And the distance is the distance between the two plates, D for short, and the voltage across the two plates. So let's say we'll have 12 volts, and on the other side we'll have 0 volts. Now pause the video here and attempt this exam question. We can start by working out what the polarity of this object is going to be. Now there's two options. We could have a positive charge or a negative charge for this object. So let's take the consideration that it's positive. If it's positive, these positive charges are going to repel, so it's going to get pushed down. And the weight is also pushing down. Therefore, there's two forces pushing down or pulling down on this object, and therefore it should be moving. So it can't be positive, so it should be negative. Now, if it's negative, we have the negatives from the bottom and the charge itself pushing each other away, and therefore we have a force going up, and we know the weight is going to be pulling down. Therefore, these forces would balance if it is stationary. Okay, so we've done the polarity. Now we can have a look at the charge. Start by writing down our equation, E equals F over Q, and we know that's equal to V over D. Now, rearranging this equation for Q gives us Q divided by F, so let's just do the reciprocal first, which is equal to D over V. Multiply both sides by F to give us Q equals FD divided by V. Now we can just plug in our numbers. We know force is 1, distance is 15 millimeters, which is 15 times 10 to the power of minus 3, divided by the voltage, which is 12. And plugging this into our calculator gives us a value of 1.25 times 10 to the power of minus 3. And the unit is coulombs. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com, where there's lots more quiz questions and resources available. See you next lesson.